Welcome to this video from in 28 minutes. Thanks for all your love, which helped us to grow to 25,000 subscribers on YouTube and more than 46,000 students on Udemy. You can find more about us on our website www.in28minutes.com. This video is a part of series of 100 plus videos celebrating my 15 years of experience with programming, design and architecture. In these videos, we talk about how to become a good programmer and a good architect. We also talk about Java related frameworks, concepts, practices and terminologies other than the varied range of tools that we make use of. You can find more details in the description of the video. Hi there. Welcome to this video on unit testing best practices. You'll find the link to the PDF that we are using down here. So it's in the repository in 28 minutes Java best practices, and you'll find a link to the PDF in here. So if you go there, you'd see the PDF we would be using in this presentation. Let's get started with unit testing best practices. The first thing we'll talk about is standards versus principles. And we'll look at a few important unit testing principles from which we'll derive a few best practices. So basically, if you look at principles versus standards, principles are generally the truth. So principles are the things which are really important. Standards are basically somebody's perspective of how principles, like what are the rules that can be derived from the principles. Let's take an example. One of the principle is code should be understandable, so readable code. So that's a principle. The corresponding standard for that, we derive a lot of standards from that. One is like you should have methods which are of length less than 20 lines. So no method should exceed 20 lines. But does that make code understandable? No, it doesn't. So we kind of derive standards. Standards don't guarantee the principle, but we kind of derive the standards from the principles, and we think applying these kind of rules will make programmers to write more readable code. Similarly, cyclomatic complexity of a method should be less than some, let's say 10. So cyclomatic complexity is basically how many ifs, for, and, ands, ors. So it's basically how many conditions are there in your specific method. So it would include all the loops, it would include all your ifs, switches, elses, and if you have multiple conditions in the ifs or elses, then it would be included as well. And also if you have like for inside a for, so loop inside a loop, or a condition inside a condition, all those kind of things will be accounted for in the cyclomatic complexity. If a cyclomatic complexity of a method is high, then it means it is difficult to understand. So these kind of standards saying, okay, your cyclomatic complexity cannot be greater than 10, and class cannot be greater than yy lines. So let's say a class cannot be greater than 500 lines, and you should not have any magic numbers in code. So these standards are derived from the principle that code must be understandable. The problem with these standards is that even if I write code which meets all these 4 standards, I cannot guarantee that the principle is satisfied. So that's the reason why we should always try and understand. When I'm programming, I look towards the principles. So standards are useful, but they are not the ultimate aim. My ultimate aim when I'm programming is to make sure that the principles are there too. So code should be understandable. That's the principle. So if that means that I have to make the method smaller, that's good. So if I have to give a good name to the method, if I have to make it less complex, that's the most important driving factor. The standards are more derivations, and for me those should not be the focus areas. The focus areas should be the principles. I can give a few examples of using standards without principles. So let's say a method has complexity 25. You can actually split it into method 1, method 2, method 3 with complexities 10, 10 and 5. You are adhering to the standard, but does that make it understandable? So that does splitting a method into method 1, method 2, method 3 make any sense? It doesn't. So similar to that, like public static int 0 is equal to 0. So I mean, what this is, you're declaring a constant, but really, I mean, what do you gain by having a constant of this kind? So you're really making 0 is equal to 0. So the name of these constants should represent some concept, some business concept, not really saying, okay, this is 0. Somebody asked me to create a constant, so I create a constant by name 0. So there is nothing you gain by that. And always, like, standards are somebody's interpretation, right? So they can change. So somebody says, okay, today I think complexity less than 10 makes readable code. Tomorrow I think complexity less than 5 makes it readable. Okay, so the focus whenever we are doing programming should be on the principles. So in this um, uh, presentation, whenever we are talking about unit testing, we are talking about uh, unit testing. So we are talking about JUnit, NUnit, and things like that. This is not really the screen integration testing performed by a developer. So to make sure that the application is running fine, that's not the testing that we are talking about. We are talking about the automated unit tests. So JUnit test written with Mockito or some kind of mocking framework. Mm, the most important thing, I mean, most important best practice as far as unit testing is concerned is the attitude towards it. So for me, unit testings are more important than code, because if I have good unit tests, it leads to better design, because if I have good unit tests, then I'm more inclined to refactor code. So I would be, because I have a test net. I mean, if I'm making if I'm making a mistake, the test net catches it. So I would be more inclined towards doing more design changes to keep the design improving, to keep the like thing called evolutionary design in play. So all these kind of things make me think that unit testing is more important than code, and that's the attitude that everybody in the organization should have. And the other important thing is that unit tests are best written before code. I mean, we call this test driven development. TDD improves design as well as code quality. Um, because tests are written before code, they would have failed, and they are testing some functionality. So if you do TDD, the quality of the test which result from that is really, really good. And also, TDD gives you the outside in perspective. So when I'm doing TDD, I always think about a class from the outside. So how would somebody be using it? So that's how you would be thinking about it in the test, and that brings in good design, because you'd make it as loosely coupled with others as possible. So you'd kind of use things like dependency injection and make sure that it's testable. Um, Obviously, unit test code should be separated from production code. It should not be part of your production deployable. And the most important thing is, writing unit tests is good, but you should also make sure that they are run very often. So what is use if I have 1,000 tests, but I run them twice a day or 10 times a month? So that's not sufficient. It's better to keep running them in continuous integration. As soon as somebody commits in code, run it. So that's kind of the most important things from the attitude perspective towards unit testing. Now, for me, these are the important unit testing principles. I mean, all the usual rules regarding code apply. So the 4 principles of simple design really apply in here as well. So you should have as less duplication as possible. You should have clarity, I mean, you should have really readable tests. You should have tests which are as small as possible. All these kind of things really apply to unit tests. So all the principles that we are talking about here are in addition, or they supplement the already existing 4 principles of simple design. So the first one is easy to understand. I mean, for me, uh, I should be able to understand what a test is doing in less than 15 seconds. So if I take more than 15 seconds to understand a specific test, it's no good. Second, tests should only fail when there is a problem with production code. What does that mean? So if, let's say, there is a row deleted from a database, your test should not fail. If there is something else going wrong, something related to the environment going wrong, the test should not fail. So that's the most important thing. The fact, like, if there's a test failure, it should be a major catastrophe. it should not be like, okay, yeah, this could be because database is down, or this could be because of something is not really working, or this should be because some service is down. So your test should not depend on either database or external services. I mean, if you have unit tests which depend on external services, then those could fail because of that, and the attitude of the programmers towards unit testing will be like, okay, they fail out of 100 times, 50 times they are failing due to some other thing. Okay, it might not be a defect. So the kind of attitude you need to have is more like, I have 100 test failures and 99 of them are really because there's a defect in code. So if you have that kind of a situation in your project, that's very good. So tests should fail only when there is a problem with your production code. The next important thing is tests should find all problems with production code. Obviously, that's the reason why you are writing tests, right? So try to write a variety of tests. All your corner cases, all your performance tests also can be written using unit tests. All your exception scenarios, you can test all of them with unit tests. So write all, I mean, try and find all the production problems with your unit tests. And the next one is that it should have as less minimum duplication as possible. So, I mean, that's kind of the constant, right? So you should not have any duplication in code. In tests, I kind of think it's okay to have a little bit of duplication, more duplication than code, but yeah, try to keep it to as minimum as possible. And the fifth one is also very important. It should run very quickly, because unit tests, if unit test takes a long time to run, then it would take 20 minutes. Let me run it later. So that's the kind of attitude which comes in. So it's important to keep the unit tests running as quickly as possible. Um, some, like, if you're in a large project and probably if running all the tests is taking time, you can kind of create suites. So keep at least one set of tests which you think are important running continuously, and you can have another set of tests, the whole volume of tests running less frequently, maybe once, like twice, thrice a day, or something of that kind. So these are the important unit testing principles. I know I have been keeping you away from code for a long while. I'll not do that any longer. So let's go and look at a few examples. So if you look at this example, like, we have a get client products sum. So what we have is a method which takes a list of products as input, and it calculates the sum of product amounts. So you get a list of products, you calculate the sum of them and return the total. And the important thing is it throws a different currencies exception if the products have different currencies. So the product have a field called currency, where you can have a US dollar or a euro or a Indian rupee, something of that kind. So if I pass in list of products which have different currencies, so if I pass a list of product with one euro product and one INR product, then it would throw an exception because the method is not built to handle that yet. So for all the other scenarios where you pass in one kind of currency, it would sum it up and it would return it back. Look at this test. So look at, try and read this test and see what it's doing. I really recommend you to pause the screen, try and understand what the test is doing. This is another way to write the same test. I would also recommend you to pause it here and try and identify what are the differences. So what is the difference between this and this? You'd see that example 2 is very easy to understand. You are clearly seeing that 5, 6 and 11 is the sum, and euro. So it's easy to understand. So that's the principle number 1. So if somebody comes in and looks at this test, they would be very easily able to understand what's going on. Let's look at some of the important differences between them. First thing is the name of the test. So if you look at the name of the test, it should indicate the condition being tested and the result. I mean, the result might not be an important thing, and sometimes it might be obvious. So I'm not so particular about the result, but I'm sure that the condition being tested should be listed. So test client product sum, all products having same currency. Test client product sum, different currencies, throws exception. Test client product sum, no products. So you can see that these are much better names than just saying test client product sum, then test client product sum 1, test client product sum 2. So you can name them better. The other thing, again, one important thing is earlier we used to really call the methods starting with test. So this was because in before JUnit 4, there were no annotations. So we had to start the methods which test, and only then JUnit recognizes them as unit tests. So now it's not really important because we use the keyword, we use the annotation at test. And so you can actually name the method as client product sum different currencies throw exceptions. So that's fine too. So, but it's more of a preference. People are used to using the test keyword to say something is a unit test. So if you are one of those category, then go ahead, use the test keyword, but it's not really mandatory anymore. The other thing is highlight the values which are important to test. See, if you look at the initial example, you have a lot of values. So product 15, bank guarantee, 100, 120. So these are not really important to the specific test that we were executing at this point. So what we were focused on is the amounts, and we were interested in adding them up. So I would rather have some kind of abstraction built around it so that I would abstract these values away. And that's what is done in the second example. In the second example, we are really focusing on the values which are important to this specific test. The other important thing is one condition per test. It's very important because the test should not have any ifs or fors or any of that kind. That's kind of a given. And the reason why you should have one condition per test is because if a test fails, you know exactly which condition is failing. And also sometimes it's useful to create assert methods to test the condition. So I'm saying assert amount expected comma actual instead of writing assert equals get currency, assert equals get value. I'm trying to create a higher level method assert amount to assert the amounts. This kind of this kind of methods also make the test more readable. The other important thing is how do you do exception handling in a test method. The thing is, if a test throws an exception, it would anyway fail. So I don't need to write code like this. So I don't need to say try, catch, fail. Nope. I can just say throws different currencies exception. That's fine enough. So what this would do is it would throw the exception, fail, and the test would fail anyway. So if the test throws an exception, it fails. So that's good. So you don't really need to do a try catch in a test. I understand that this is not something which you do in typically in code, but in tests it's okay. It's okay to use to say a test method throws exception because nobody is going to call this method. The other important thing is to use the annotated exception handling to test for exception. So you have a at test expected is equal to different currencies exception dot class. So if you are expecting an exception, then use that rather than saying try catch and writing all the logic around it. So if you are expecting an exception to be thrown from this, just say at test expected is equal to this. And if that exception is not thrown, the test would fail. And if that exception is thrown, then the test would succeed. And also try and use the new features. So these make the code easy to understand. So to compare arrays, use assert arrays equals. To test exceptions, use the assert annotation exception is equal to specific exception dot class. You also have an annotation for testing performance. So you can just say timeout is equal to how many milliseconds you would want the test to run in. The moment the test takes more longer than that to run, this test would start failing. Okay, the other principle that we were talking about is code should fail only when there is a defect in the code under test. They should not. The most important thing is that there should not be any dependencies between test conditions. So if there are conditions 1, 2, 3, 4, 5 being tested, you should not assume that 1 would be run first, 2 would be run next, 3 next, and so on. JUnit does not guarantee the order, and you should not assume the order in the test. The second one is avoid external dependencies. Don't depend on database, external interface, network connection, or a container. Try and stub and mock them out. And the other one is, this is something which I keep seeing. So avoid depending on random and system date. So if you have something depending on system date or random, those can fail because if your code depends on a specific date or something of that kind, then that kind of code fails. Obviously, hard coding paths also is not a good thing, obviously. whenever I move it to some other build server, let's say I'm running the test on there, this path would not be there and it would start failing. So don't really depend on anything external. The principle 3, test should find all defects in code. Yeah, that's the reason why you write tests, right? So test everything that can break, exceptions, boundary conditions. Try and use strong assertions. I mean, what's the use of having a test if it is not asserting values? If I mean, it's waste of time to write tests for coverage. Uh, yeah, so like this is one of the favorite magazines of mine from the JUnit FAQ. It says test until fear turns to boredom. So test until then. So as long as you are having a little bit of fear whether something would break in the code, write a new test, write another test until it becomes boring. So, I mean, how many tests to write is something which you would really learn with experience over a period of time. Do not worry about it. Try and write as many tests as you can and have fun with that. The next principle, ups, is the same principle. Tests should find all defects in code. So again, there are a lot of things like, should we really test setters and getters? I mean, setters and getters. Yeah, so I really like this thing from the JUnit FAQ. So it says, start with testing everything. You do it over and over again, so you become more aggressive. You start writing lesser tests, and then you'd start writing tests for most interesting. So you limit your testing for only interesting scenarios, and then you get burned by a stupid defect. You feel stupid, and then you start writing tests again, a lot of tests, and then this cycle goes on and on and on. This is an infinite loop. Obviously, less duplication. I don't really want to have any discussion except the fact that in tests is, I think, allowed to have a little bit of duplication here and there. I wouldn't be as strict in tests as I would be in real source code. Tests should run quickly, obviously, so you avoid reading from file system or network. So a temporary solution, as I'm talking about in here, can be to collect long-running tests into separate test suite and run it less often. If you follow all these principles, then tests can act as your documentation as well. So if you look at this, it says test client product sum, all products same currency. You can see how readable this piece of code is. Test client product sum, different currencies throws exception. Test client product sum, no products. So these are really readable tests, and these are conditions you can use for discussion with business as well. So this results in tests acting as documentation. So there you go. Those are the important things that I wanted to share with you regarding JUnit tests and best practices related to them. There is a lot of videos that we created on JUnit, and we have courses on Udemy on JUnit as well, so you might be interested to check them out. I believe that unit testing is as important as coding. I also believe that test-driven development is the best way to do programming. If you have any questions, leave them in the comments, and hopefully I'll get to them. Thanks for watching this video. We created this video to celebrate my 15 years of experience with design, architecture, and programming. We have created 2 complete Git repositories for you: Java Technology for Beginners and Java Best Practices. Java Best Practices covers my 15 years of experience with design patterns, code quality, design, architecture, and modern development practices. We talk about REST services, SOAP web services, microservices, cloud native applications, 4 principles of simple design, among a varied range of other topics. It tells you how to become a good programmer, designer, or an architect. Java Technology for Beginners focuses on the frameworks, concepts, practices and terminologies and tools related to application development. You can find link to the repositories in the description of the video. In 28 Minutes has some of the highest rated courses on varied range of topics. You can find more information on our website www.in28minutes.com.